Transformer on no load. It consists of two windings, that is, the winding which is connected to the AC source is known as primary winding, and the winding which is connected to the no load is known as secondary winding, that is V2. Under no load condition, it draws the current of 2 to 5% of its full load current. It produces flux phi in the core. It is made up of laminated stampings to reduce eddy current losses in the core. The current I0 is produced at the voltage V1 due to the alternating flux phi will produce an EMF E1 at the primary winding respect to E2 at the secondary winding. The induced EMF will get lag by 90 degrees with the flux. The no-load current I0, which is taken by the primary, consists of two components. That is, magnetizing component and active component or working component. Now let us discuss about the phasor diagram of no-load transformer. Now let us take the reference as a flux phi, and we know that the EMF induced will be lags by 90 degrees, that is E1. Now let us extend the E1 in the reverse direction with respect to E1, that is minus E1. IW supplying the iron losses and negligible copper losses in the primary winding. So IW is in phase with E1. I mu is in phase with the flux phi. Therefore, the resultant of these two vectors gives the current I naught. Hence, the load current I naught lags supply voltage by an angle phi naught. Hence, cos phi naught is the no load power factor. From the phasor diagram, we can write I naught equals to square root of I mu square plus IW square, where I mu can be found by the product of I naught into sin phi naught, and IW, that is working component, can be found by I naught into cos phi naught. On no load, primary copper losses are negligible. Thus, no load primary input power is equals to iron losses occurring in the core. Therefore, W naught equals to V1 I naught cos phi naught.